Next, we'll look at domain and range for functions as graphs. We will write down the domain and range using interval notation. Remember, the domain of a relation is all of the input or x values that the relation includes. In order to find the domain of the graph, I want you to look at the endpoints of the relation graphed from left to right. We will include all the values in between the two endpoints as long as the graph is continuous. The range of a relation is all the output or y values that the relation includes. In order to find the range of the graph, please look at the endpoints of the relation, but this time we're going to be looking from bottom or lowest to top or highest, because the range is looking at my y value, so we're going to go bottom to top. On this first function, notice that we have arrows. This means that the function keeps going in this direction forever to the left and forever to the right. I would like you to first look at your arrows, and if they're going not vertically or horizontally, but what we might call slanted or at an angle, I want you to think about each of those arrows as two components. This arrow, which is going down and to the left, is going left forever, but it is also going down forever. The upper arrow is going up forever and to the right forever because it's at an angle. Not vertical, not quite horizontal, so it's going at an angle or up forever and right forever. When I'm looking at the domain, I'm looking for the endpoints of the relation graph from left to right. Or how far left does this function go? Well, this arrow right here tells me that my function goes left forever. How far right does this function go? Well, this arrow right here tells me that my function goes left forever. So my domain is negative infinity to positive infinity. Similarly, when I'm looking for the range, I'm looking for as low as my values can go and as high as my values can go, and I'm going to include all the values in between them. The lowest I can go is infinity. Notice that this arrow right here tells me I can go down forever. Similarly, this arrow tells me that I go up forever. So when I'm looking for my range, how low can I go? Well, negative infinity. How high can I go? Positive infinity. On my next function, I have again these arrows that are going off at an angle. This arrow on the left hand side tells me that I'm going up forever, but that I'm also going left forever. It may be going up a lot faster than it's going left forever, but I need you to understand that that does go left forever. The direction this angle is going up and left forever. The other arrow is going up forever and right forever. To look for my domain, I'm looking for how far left can my function go and how far right can my function go. Well, this arrow here tells me my function go forever left, and this arrow here tells me my function can go forever right. So my domain is negative infinity, comma positive infinity. When I'm looking for my range, both of these arrows tell me that I go up forever, although I don't go down forever. So I need to really look for my lowest point, comma my highest point. Well, how low on my y-axis do my values start? Well, it looks like my y values start right here at -1. And how high do they go? Well, they go up forever. I'm allowed to include -1, so I use a bracket. I'm not allowed to include infinity, so I use a parentheses, and that is my range. On the next function, you have to be a little bit careful. These arrows are pointing down forever and also left forever. The next arrow is also pointing down forever, but it's also going right forever. From the left, this arrow here tells me it goes left forever, and this arrow here tells me it goes right forever. My domain must be negative infinity, comma positive infinity. Although my range has two arrows pointing in the same direction, they both are going down forever. What is the lowest value that my range has? Negative infinity, because both of those arrows are telling me that I'm going down forever. Comma, how high does my function reach? On my y-axis, I'm looking for the highest value, and the highest value that I see is right here at 4. The lowest value can be is negative infinity, comma, the highest value is 4. On the next graph, notice that we don't have any errors at all. We have an endpoint on the left and we have an endpoint on the right. So when I'm looking for my domain, I'm looking how far left can my value go on the x-axis and how far right can my value go on the x-axis. It looks like my function starts on the left at -3 and it ends on the right at +4. The lowest my value can be in the x direction is -3, comma, the highest my value can be in the x direction is +4. Can I include my -3? Absolutely, so I put a bracket. Can I include my 4? No, so I put a parentheses. When I'm looking for my range, I'm looking for the lowest the values can be on the y-axis and the highest the values can be on the y-axis. Not necessarily the endpoints of the actual graph, but the lowest it can be, comma, the highest it can be. So when I'm looking at my y-axis, the lowest value on my y direction is 0, comma, how high can it be? Do I stop here because that's where my endpoint is? Well, no, because I have more y values higher than it. I can go all the way up from 0 to 1, 2, 3, 4. So my range is 0, comma, 4. Can I include 0? Absolutely, that's a closed point. Can I include 4? Absolutely, that's also closed. On the next two graphs, we have this dotted line through the middle of the graphs here. This may be your first introduction to this dotted line called an asymptote. We'll be using asymptotes several times this semester, so this is a good place to introduce them. This graph gets really close to your asymptote, although it never reaches your asymptote. And that's what an asymptote does. It is a boundary line for your actual graph. The actual graph is the black lines. The blue dotted lines are only a boundary, so to let the reader know where the graph is approaching to, yet not ever crossing, and that's what an asymptote is. Let's look at the first function. Again, we have arrows, so I'm going to look at the arrow and say this vertical arrow goes up forever, but it also goes left forever. It may look like it's going straight up, but it really is continuing out, so it does go left forever. Even though it's going up forever faster, it does continue to go left forever. Now the other arrow is only going right forever. It won't continue to go down forever because of the dotted line. The dotted line asymptote tells you that the line will never ever go below that value. When I'm looking for the domain, how far left can I go, comma, how far right can I go? This arrow tells me that I'm going left forever, and this arrow tells me that I'm going right forever. So my domain is -infinity, comma, +infinity. When I'm looking for the range, I'm looking at the y-axis. How low can my values go on the y-axis, comma, how high can my values go on the y-axis? My values start at 0, and they continue all the way up forever, because that's what that arrow tells me. So my range is 0, comma, infinity. We know there's a parentheses on all infinities, but the question here is, do I use a bracket on the 0 or do I use a parentheses? Well, that goes back to the definition of an asymptote. The black line, which is the function and the range that I'm looking for, will never ever cross or reach the asymptote. So it will never ever reach 0, but it gets infinitely close to 0, which means 0 is my endpoint, yet not included, so we use a parentheses. On the last graph, let's look at the arrows. Because we have asymptotes, the left arrow is only going left forever. It will not continue to go up forever. It reaches its boundary point at the asymptote. Similarly, this arrow goes down forever, yet it won't ever cross the asymptote, so it does not go right forever. Similarly, this one goes up forever and this one goes right forever, but will not ever cross those asymptotes. When I'm looking for my domain, I'm looking how far left can I go, comma, how far right can I go. Although I have a problem here, because my two branches of my graph are separated by an asymptote. I can have all the values right up until my asymptote at -1, and then I can have all the values to the right of -1, but I'm not allowed to have a value at -1. The definition of an asymptote says my graph gets infinitely close to it, but not crosses it. My domain would be -infinity all the way up until -1, not including -1, union all the values from 1 to infinity. This means all real numbers except -1. Make that a -1 right there. My range is very similar. This arrow says I go down forever. This arrow says I go up forever, but the one value I'm not allowed to have is my asymptote at -2. I'm allowed all values below -2 all the way right up until the asymptote. Then I'm allowed to have all y values above negative 2, but I have a hole right here at negative 2. Therefore, my range is negative infinity all the way up to negative 2, union negative 2 until infinity.